Hello, this is my 212 graphics programming demo showing you what I've done for my Hovercraft game. So to get started, we'll show off the texturing. So as you can see, I've textured a windmill, the hovercraft, the racetrack, and the grass field, and then I'll go into the skybox and stuff later. So the hovercraft, I just did two textures on it, just so it looks a little bit nicer. And kind of the way I textured all this was I read the 3D model file and then I applied the texture using texture coordinates in OpenGL instead of applying the material in 3ds Max, just because I thought it was easier and simpler to do that way. Looking at the track and the grass, you can see some mip mapping. So closest to the hovercraft, obviously the resolution's full scale. A little bit further away, it's slightly reduced. You can hopefully see it there. And then furthest away from the camera, it's reduced a lot. So if you look on the screen now, you'll be able to see a diagram showing mip mapping. Basically, the way it works is if you just take an 8x4 texture, for example, it uses different levels. So the closer to the camera, the higher the resolution of the texture will be, and the further away. So say, for example, on level 2, the texture is 2x1. So obviously that will be further away because it's a lower resolution texture. I used the OpenGL command gl underscore nearest underscore mipmap underscore nearest, which is basically one of the 4 mip mapping techniques or commands. It's got the worst quality out of the 4, but it's the best in terms of computational processing time, basically, or cost. And to be honest with you, looking at it, I think it still looks pretty decent. And if it's the most efficient, I thought I might as well use that. The racetrack also has mip mapping on it, just so it doesn't, the lighting of the racetrack doesn't look different and weird when compared against the grass field. Moving on, we've got the skybox. So we've got 4 corners, I guess, and then we've got a floor, and we've also got a ceiling. Looking at the diagram on your screen now, you can see how a skybox is kind of generally drawn. So you've got image is basically divided up into 6 sections, 1 for each wall, I guess you could say. For example, 5 and 6 is the floor and the ceiling of the skybox, and then what you do is you apply that texture individually to each wall. Which, isn't too bad. It was quite simple to do. Next, moving on to different cameras. That's something that I spent a little bit of time on. So this is the default camera. Then if we move on and press V, sorry, we then have the top-down camera. So if I just go over to the part of the track that it's actually on, because I didn't want to put the top-down camera showing the whole track, I thought it would be cool to just show off one part of it, just simply because it would then... Like, this is like the longest point, so it's the fastest, so it would be cooler to see people driving there. The fastest, hopefully that kind of makes some sense. And then the third and final angle is the same as the first, but slightly scaled backwards. And then you can interchange all these camera angles, obviously at runtime and multiple times. It's not like you're set to doing it once. So yeah, another thing that I implemented was my FPS counter. Now, that can be seen on the console. I didn't manage to get it working in the UI itself, but it's in the console, and as you can see, it's capped at 144 frames per second, and that's because the refresh rate of my monitor is 144 Hertz, so it's capped at that. It runs at that completely fine. There's absolutely no issues whatsoever, which is always good. Okay, so hi guys, this is my lighting in my game. So as you can see, there's one kind of point where it hits, which is the windmill. The light source is actually up here in that grey collider. I'm not sure how well you can see that, but it is there. You can look in the source code. And then if you look at the lighting from behind, obviously there isn't any lighting on it because the light source isn't facing that way. That's kind of the only lighting that I've got in my game, which I'm a bit disappointed with. I thought I'd be able to get more in, but I just didn't have time. If I was to implement it again, I would use Fong's lighting model. I've managed to kind of show you and draw and show some diagrams to you guys, which are on the screen now. Basically, it uses 3 different methods. So you've got the ambient section, diffuse, and then specular lighting. Ambient lighting basically illuminates everywhere equally. Diffuse lighting, it kind of like it adds depth to the kind of the lighting is probably the easiest way to explain it. And the intensity of the lighting depends on what angle you view it at. So that's the image on the left. That's how that's calculated. And then specular light's kind of the image on the right. So that's kind of... You've got the depth to the image, and then you're adding like a bit of a reflection, a bit of a shine onto it, and that's based on position as well. And then another thing I'd probably look into is attenuation of light. So that's basically how the light kind of fades and loses its intensity the further away you go from it, which is kind of like something that I think could look really interesting and quite cool with certain effects.